Now, it's not a compile time error just because here we have calculate interest, and even the second method name is also calculate interest. And the three things in the method signature is first number of arguments, data type of the arguments, and order of the arguments. So if at least one of these three things are changing for a method and if the method name is the same, then it is called as method overloading. Now, can I call these two methods as overloaded methods? No. Or yes? Signature is changing. Okay, for method overloading, name of the method should be the same. The name of the method is same and the signature is changing, then only it is called as overloading. Okay? Now, one is R and another is P. The signature will be verified against the data types, not the identifier names. The signature will be verified against the data types, not the identifier names. Identifier names will not be considered in the signature. In signature, only data types will be verified. If data types are the same, then it is said to be duplicate. Now here, number is the same, type is the same, and if there is only single argument, there is no concept of order. If there are multiple arguments, then there is a concept of order. If there is a single argument, then there is no concept of order. So here, these two methods are said to be duplicate methods. It will give a compile time error. It's already defined in member demo, so it is a duplicate method. It's already defined, so it's considered to be a duplicate method. Now, what is the output? It is 1 or 2? Now, if I ask what is the output, it might be a compile time error, or it might be a runtime exception, or it might be a correct output. Is there any compile time error here? Yes or no? No, just because if I consider these two methods have the same name and the same number of arguments, but the data type of the argument is changing. If at least one is changed, then those two methods are said to have different signature. And as long as the signature is changing, we can keep a number of methods with the same name in the same class, which is called as overloading. Now what is the output? Is it a compilation error? Why it should be defined before the main? See, compiler will not verify it is there before that method or not. It will not verify like that. The compiler will verify whether that method is there in the class or not. Wherever it might be before or after or at the end or is irrespective. The compiler will verify whether that method is there in that class or not. It's not before or after. It can pick up wherever it might be in that class. Okay? No. Will it be a compile-time error? Yes. Why it is a compile-time error? On-static method cannot be. Which method we are calling? The first method or the second method? What is the value that I am sending? Integer or double? Integer. Now, if I am sending integer value, will it go to the second method or the first method? No. If I call the first method from the main, then it is a compile-time error. Am I calling the first method? No. It tries to link this statement. The statement is the seventh method. The method call will be linked to this method. Just because the value that I am sending is an integer. Now, first it will try to fetch exact data type. Wherever it might be, not the first or second. It will not try to fetch the first method or the second method. It will not fetch the methods in order they are fetched. It will check the suitability. So wherever it might be, it will check the suitability. Okay? It will pick up the best suitable method. It will pick up the best suitable method. Now, is there any method which takes the integer? Yes. There is a calculate integer method which takes integer exactly. So it will come to the second method only. Why it should go for the first method? Okay? The compiler will pick up the best suitable method. Wherever it might be in the class, before the method declaration or after the method declaration or wherever it might be in the class, the compiler will pick up the best suitable method for the method call. So, what is the best suitable method for the method call? Definitely the second method. Just because the value that I am sending is integer and the argument here is also integer. So, since I am calling the second, since the compiler will try to link the call to the second method, it is not a compile-time error. Understood? The compiler, in this statement, we have a method call. The compiler will link that method call to the second method, not the first method. If the compiler tries to link the method call to the first method, then definitely it will be a compile-time error. Just because first method is non-static and it is referred from a static method. Now, let me make like this. Now, let me try to compile this. It was compiled successful, and now what I'll do is now we'll give a compile time error. Yes. Now we'll give a compile time error? Yes. Why it was not giving a compile time error previously and why it is giving compile time error now? Previously the second method output is seen which was exactly matching. Now is there any exact match for the values that I am sending? No. So it will go to the next level. Long. Is there any long? No. So it goes to the next level. Float. Is there any method which takes float? No. So that it goes to the next level. Double. Is there any method which takes double? Yes. So it tries to link the seventh statement, the calling statement tries to link to this method. But this method is non-static. And the non-static method is directly referred to my static method. Then it will be a compile method. Understood? Understood? Now, if I try to compile this, now it is a compile time error. Non-static method calculate interest of double cannot be referred from a static member. Okay. Now, will it be a compile time error? If there is no compile time error, you can analyze the output. And what is the output? Those who tell, you think that it is error, raise your hands. If you think that it is an error, raise your hands. Then only 3. And if you think that it is not an error, raise your hands. If you think that it is not an error, raise your hands. Okay? It will be a compile time error. Just because, see, don't try to link first. First, try to analyze the methods. If there is no compile time error in the methods, then try to link the calling statement to the call statement. Now, let's check the first method. What is the return type of the first method? Integer. What I told while discussing the methods? For each and every method that has a non-void return type, it should return some value of the data type. Now, what is the return type of the first method? What is the return type of the first calculate interest method? Int. Now the return type is int. Does it have any return statement? No. The result is a compile time error. Okay. So first analyze each and every component as individual. Now each and every component as individual is compiled. Then try to link the calling statement to the call statement. So first, the method itself is not compiled. Then how can link the method called to this method? First, try to compile each and every component, each and every member as individual. If each and every member as individual is compiled, successful, then try to link the method called to the specific method. Okay? The first method itself is a compile time error. Just because the return type is int and it doesn't have a return statement. So, if I try to compile this, it gives at the 15th statement we are expecting a return statement, but there is no return value. We should return some value. Now, what is the output? Two? Will it give 2 or something else? 2, just because it has a direct match. Okay? It has a direct match which takes a integer. No? 2. What's the output? 1 or 2 or compile some error or something else. Just analyze the example, think about the answer, just I'll execute the stuff and you yourself can come to know whether the assumption is correct or not. Will be compiled successful because there is no compile error. And is it come to 1 or 2? 1. Why it is not coming to 2? Is there any specific reason why it should not come to 2? Okay. Can short accommodate 0? Can short accommodate 0? Short can accommodate 0. Short can accommodate 0. But by default the compiler for 0 what it will do? It will make 0 as a integer. By default the compiler will think 0 as integer. But it's not that short cannot accommodate 0. Short can accommodate 0 if it is typecasted into short. Short can accommodate 0 if it is typecasted into short. Short can accommodate 0. But what the compiler will do is, the compiler by default it will think 0 as a integer. So, is the second method matches exactly? No. So, what it will do? It will go to the higher level. There is no int exact match, so it goes for the higher level. What's the higher level for int? Long. Is there any method which takes long? No. So, then float, then double. Like that it will take. So, it will go to the first method. Just because by default fraction numeric is double, non-fraction numeric is integer. These kind of questions will be asked if you go for written test. Okay? Here itself many of the candidates will be filtered. Now what is the output? What is the output? What is the output? Again telling 1 and 2. That's why I told, don't think only about the current concept, even concentrate about previous concepts also. Will it try to link the first method or the second method? Definitely the second method, just because we are typecasting 0 to byte. Now we are passing a byte. Now, what is the least data type? Byte. Okay. What is the higher data type to byte? Is it short or int? Short. After byte it is short. So it will prefer the next higher value which is short. But is the method static? No. The method is non-static. So these two as the individual methods, these are compiled successful. Just because the method name is the same and the signature is changing. The data type is different. So these two methods as individual, they are compiled successful. But when we try to link the calling statement to the call method, we will try to link the first method or second method? Second method. If we try to link the second method, definitely the second method is non-static. which is called from a main which is static. So it will be a compile time error. Understood? Yes, it is telling that it tries to link to calculate interest which is short, but there is a non-static method which is used. No? The return time is different. Then the return type is different. It's not the same. Previously, we used to have the same return type, but now the return type is different. Previously, we used to have same return type, either void, or int or something like that. But now, the return type itself is changed. If the return type itself is changed, what happens? Only? Which method is considered for execution? The first method or the second method? Okay. While verifying duplication of methods, the compiler will never verify the things that are left hand side to the method name. The compiler will just verify the list of arguments, that's it. The compiler will never verify with the return type or the access modifier. The compiler, while checking for duplicate methods, the compiler will verify only with the method name and the list of arguments, or simply the method name and the signature. The compiler will never consider the return types or the access modifiers. The compiler will never consider the return types and access modifiers while checking for duplicates. So, the compiler will consider two methods as duplicate if the method name is the same and signature is the same. That's it. It will never check for the return type or access modifier or anything. The compiler will consider two methods as duplicates if the name is same and signature is same. Whatever the return type it might be and whatever the access modifier it might be. Two methods are said to be duplicate if the method name is the same and signature is the same, irrespective of the return types. So, can I consider these two as duplicate methods? Yes. Whether which method is called at the runtime is different, but at the compilation time itself, these two methods are considered to be duplicate methods. Return type is not considered while verifying the duplicates. Now, can I tell return type is not considered as a parameter, or return type is not considered as a constraint in method overloading? Can I tell that return type is not considered as a constraint in method overloading? Definitely yes. Return type will never be considered as a constraint while method overloading. Okay? Return type will never be considered as a constraint in method overloading. Method of overloading, the only things that are considered are method name and signature. Method name and the list of arguments. The return type will never be considered. Now, is it error? Yes. One calculated interest is double and another calculated interest is float. Float and double, those two are different data types. Those are not similar data types. Why do you think it is a compile time error? See, here in the sixth statement, which method we are linking? To the first method or second method? Definitely the second method, just because for 0 it is a int, it will go for the next level long. The next level is float. Now which method is linked, first method or the second method? Definitely the second method. But for second method, what is the return type? Void. But we are expecting to assign it to integer. Then the return type should be integer. We are expecting the return type should be integer, but the actual linked method has a return type void. Understood? Now it will be a compile time error. The actual linked method is void return type, but we are trying to assign it to a integer value. If we are trying to assign it to integer value, it expects a integer return type. The actual return type is void. Now, will it compile successful? Definitely yes, just because first it will try to find the exact match int. If it is not found, then it will go to the next level long. But long match is found, and what's the return type of long? Integer. Now can I assign this right hand side to left hand side? Definitely yes, just because calculate interest returns integer and left hand side it is integer. So that likewise step by step we need to check whether the things are possible or not. We should not compile as a whole. First we should compile individual units. If individual units are compiled, then we need to check this stuff, overloading and the related duplication stuff. Once those are compiled, then we need to try to link the methods, and then from there we need to analyze. Okay, like this, try to make out several examples like this, and you may find several new things. Okay, there is no limit for such examples. You can make n number of examples, and even in tomorrow's class we'll discuss some more examples like this, which will be making some errors in common. Okay, and then we'll switch over to next concept. Okay.
The last block, what is the last block? Last block.
Okay, it was a mistake, but even this is called as initialization block. Just while erasing, it was a mistake for me. And actually, this is a possible block in a class. This is called as initialization block. That we'll discuss later. Okay.